So this one is an exponential equation. The variable is stuck in the exponent as opposed to the last two where the variable was in some way stuck in the log statement. If we want to get rid of an exponential statement, I'm gonna yawn, sorry guys, we need to use logs. The truth is you can use any log you want. Log properties will allow us, even if our log base doesn't match our exponential base, to move the power down in front. My advice is to be smart about choosing your logs. If you want to cancel out an exponential with base 3, the neatest, cleanest way to do that is going to be to use a log base 3. So I get a log base 3 of 3 to the x equals log base 3 of 7. Okay, so you can take the log of both sides of an equation, and you should choose that log carefully to give yourself the least possible amount of work. Log base 3 of 3 to the x should just give me x. What power of 3 is 3 to the x? Those are inverses. And log base 3 of 7 is nothing particularly nice. If I had the log base 3 of 9, I would be asking myself what power of 3 gives me 9, and I would say it's 2. But if I'm asking myself what power of 3 gives me 7, it's certainly not any sort of nice, easy to write down power. So this is a completely acceptable answer. That's one of the things you want to get used to in this section is your answers can involve logs. You just don't want any variables on this side. So the log base 3 of 7 is just a number, and that's a completely acceptable answer to an equation. So to get rid of logs, we use exponentials. To get rid of exponentials, we use logs. On the fourth one, we're back to a log equation. So here, if I want to eliminate a log base 1/2, I will exponentiate. And as you get comfortable, I'm okay with not seeing this step. I want you to understand that that is the steps that gets rid of the logs. But if you can see what's happening here, you don't have to write out the exponentiate step for me. Okay, so this is what I end up with, and this actually works out beautifully. This equation might have looked messier at the beginning, but it's going to clean up really nicely. Both sides we have a log that can cancel out. So I'm left with just 2x plus 1 equals x plus 3. And that's just a linear equation. So I'm going to subtract x from both sides. And I will get x plus 1 equals 3. And then I'll subtract 1 from each side and get x equals 2. Oh, and I boxed that off, but this is another one. We started with a log equation, so there's a not optional check here. If I plug 2 in, I get the log for 5, which is completely legal, log base 1/2 of 5. And on the other side, I also get the log base 1/2 of 5, which is not only also legal, meaning that it's definitely not extraneous, but I got the log base 1/2 of 5 equals the log base 1/2 of 5, and I am confident that that is a true statement, so that's definitely a good solution.